Goodness gracious. Mr. Flick is calling me for some reason. Oh, he doesn't have a second period. That's why. Oh, Bill. Okay. So anyway, C prime is measured in hundreds of calls per hour. Okay. So that's the rate they're getting calls, which means the integral of that will be the number of calls if they ask us to do that. Okay. The derivative of it is the rate of change of the rate they receive calls, which is super wordy. But either way, we go from 6 p.m. to 2 a.m., which is from 0 to 8. They switch that over to hours. And the first question is just approximate C double prime of 7. And that should not be too bad, right? To find the derivative of this function they've given us, okay, or to approximate it, we use the data we're given. So we got to find the slope between 6 and 8. So that's going to be 0.2 minus 1 over. And we're going to write C double prime of 7 is approximately equal to just 0.2 minus 1 over 8 minus 6, which is negative 0.8 over 2, right? That looks good, which is negative 0.4 hundreds of calls per hour. Oh, no, hundreds of calls per hour squared. So this is, again, super wordy, per hour squared. All right. And remember I told you how to explain what a derivative means. I'm going to type it over here. Let me get my fancy keyboard. So we're going to type let me make this a little bigger so everybody can see it over there. Let's go like 22. That'll be good. Okay. So when you explain what a derivative means, all you're going to do is name the function you're talking about. Okay. So they said C prime of t is what's the word they use? They say it's the rate that the pizza chain receives calls for delivery. Okay. So the rate that the pizza chain receives calls for delivery. And then you say it's increasing or decreasing. So it's decreasing because the derivative of it was negative. All right. You can say negative 0.4, but that also means 40 calls per hour. Cool. But you can also phrase that as at 0.4 hundredths of calls per hour. Let's get out of here. All right, so again, just to highlight this, when you explain what a derivative means, you don't name the derivative, you name the function. I'm saying the rate here initially because the function that we're looking at is the rate they receive calls. So I'm just naming what it is, what I derived. The rate the pizza chain receives calls for delivery, and then you say, is it increasing or decreasing? That's the second part. That's what the derivative tells us. So it's decreasing at whatever, and then put the units. All right, so hopefully we're all feeling pretty good there. If you got a question, just unmute and throw it out there. Okay. So this says, do the data table support that there's a time where there must be 300 deliveries calls per hour, basically? That's an IVT question, and it's an IVT question because they're asking about the function that's in the table. So remember that. If they ask about the function that's in the table, which is the rate at which they receive calls, all right, they're asking, does that ever hit 300? Well, yeah, because here it's 500, right? Here it's 100. Here it's 20, really. Here it's 250. So because it goes from above 300 to below 300, then yes, it has to go through 300. We got to write that out using IVT. But first, we got to state that we can use IVT, but only we can use it if it's a continuous function. But they tell us right here in this problem that this thing is differentiable. And if it's differentiable, it's continuous. So we're going to say yes. Since C prime of t is differentiable, in my sloppy handwriting, is differentiable, that's what that says. And thus, I love the word thus, continuous. I should have typed this out too. So it's differentiable and thus continuous. And C prime of 0 is 500, which is greater than 300, right? Let's get this out of here. This is from an old question. Which is greater than 300, which is what they asked about, which is greater than C prime of 8, which is 20. So basically we're saying, hey, it's continuous and 300 is between these two values. So there is a time when C prime of t equals 300 by IVT. Okay, the other kind of question you might see from this, and again, if you have a question, just holler at me, is MVT. They might ask about, so if they asked you, just if we take a look at this real quick, that they don't do it on this question, but a lot of times you might see this, like the average rate of change on this table from start to finish is 0.2 minus 5 over 8 minus 0. Okay, that's just the y value here, the y value here. You can also use the 20 and the 500, but let's use the numbers they gave us. 0.2 minus 5 is negative 4.8. That's an equal sign. Over 8. Okay, and that's going to reduce down to, if you divide all that by 4, what? Negative 1.2 over 2. Well, that makes sense. Negative 0.6. Okay, so they did not ask it in this question, but it would not be unusual for them to say, must there be a time where C double prime, does C double prime have to equal negative 0.6? And they'd use the units there, and they'll ask that question. And then you're going to say by MVT, yes. And you're going to say all the conditions for MVT, and then you're going to show that the average rate of change is negative 0.6 of C prime of t. So C double prime of t has to equal negative 0.6 at least one time between 0 and 8. Okay, so that's that. All right, by the way, this is the person I stole these from. Cool. And they came from another teacher who was not this man. So I have no idea who that guy is, but thanks a lot, Brian. Okay, so explain what the integral of C prime of t does. Well, if we integrate from 0 to 8, so let's answer that question first. C prime of t dt. Remember, first off, if this is in hundreds of calls per hour, if C prime is in that, then the integral of C prime is going to be in hundreds of calls. Okay, that's what integrating does. It gets rid of the x value, the x units, the time units down in this case, in the denominator of our units. It multiplies by hours basically, right? Because there's a dt at the end of it. But if you integrate a rate of change, you get the total change. We've talked about that. Okay, so when you integrate C prime of t, it's going to find the total number of calls in hundreds per hour. Okay, from t equals 0 to t equals 8. That's what the integral of a derivative tells us, the total number of things that happen, the total amount of change. Okay, and then it says use a right Riemann sum with 4 subintervals to approximate this. And hopefully you guys are feeling okay with that. I know we haven't spent a lot of time doing this, but a right Riemann sum for this, I'm going to do it up here. It's going to have, so this is really part C. It's going to have 4 intervals because we have 4 intervals, right? 1, 2, 3, 4. Okay? It's not 4 x values, it's intervals. Every interval has 2 x values. So the integral from 0 to 8, C prime of t dt, and note this little subtle thing. It doesn't equal this, it's approximated by this. Get this out of here. It's a right Riemann sum, right? I'm pretty sure it's a right Riemann sum. Let me check before I mess up. Yep, right Riemann sum. So our first interval is 0 to 1. And you can graph this out, but that has a base of 1 and a height of 4.5 because I'm taking this first interval. Remember, it's just a rectangle. The base goes from 0 to 1, and the height on the right-hand side of that's going to be 4.5. Plus, my next rectangle goes from 1 to 4. That's a base of 3 and a height of 2.5. Plus, my next rectangle goes from 4 to 6. It's a base of 2 with a height of 1. It's the right-hand side there. And then 6 to 8 is a base of 2. Get out of here. Plus, base of 2 and a height of 0.2. And I'm not even going to simplify that. I'm just going to leave it just like that. And we're going to write hundreds of calls. Does hundreds have an apostrophe on it? I don't know. I keep putting it on there. Right? No. I don't know why. Why do I put that on there? Whatever. Hundreds of calls. That looks awful. Okay. Everybody feeling good? Thumbs up? Head nod? Great. Talking to my screen? Cool. It's like you get a little glimpse into my life. I'd be doing this if you guys weren't here anyway. This is nice.
Mr. Smith,
Yeah.
how come you said in part C, the integral from 0 to 8 of c prime of t finds the total number of calls in hundreds per hour? How come you said hundreds per hour instead of just total number of calls from that time?
Because our units are going to be in hundreds of calls per hour. Just sometimes when the numbers are bigger, like hundreds or thousands, they just chop off the 100 part or the 1,000 part. So like the answer we get when we integrate this is actually going to be, basically, like if we did this all out here, right, like 4.5, and we did all this workout, we got somewhere around like 20. It's not 20 calls, it's 20 hundreds of calls. Does that make sense? Which means it's really 2,000 calls.
Okay.
Okay. I'm just using the same units they're using here, man. So those numbers don't represent calls. That each one represents 100 calls, basically.
Okay, and then how can we say per hour if it's just hundreds of calls?
Did I say per hour? In hundreds per hour. Oh, in hundreds.
Okay.
There you go. That was a good question. Okay, yeah, it's just in hundreds. Okay.
Gotcha. Thank you.
Yeah. All right. This is them doing like a little related rates kind of thing to us here. Okay, so they're saying the total number of calls they receive on a Friday night in hundreds of calls, okay, can be modeled by this function. Boom. Where X is the number of delivery drivers. So basically, for some reason, the number of calls they get is dependent upon the number of delivery drivers they have. Okay, which seems like it should be the other way around, but whatever. So when there are 60 drivers, that's X. So X is number of delivery drivers. Follow our units. When X is 60 is what they're giving us, the number of drivers is decreasing for whatever reason at 7/24. So let's pay attention to our units here. And that's drivers per hour. So they're telling us at this point in time, X is 60 and it's decreasing. Its rate of change is negative 7/24. That's what that sentence tells us, okay? And you want to pay attention to questions like that, not specifically for an AP test, just the wording of it. If it says, like, it's decreasing at this per hour, but the units in your function aren't hours, well, then this has to have, like, a second, like, a derivative. It has to have a chain rule. It's got to be, like, a rate of rates kind of thing, okay? And usually you see that with, like, volume and area. We've done a lot of related rate questions with that, but it could be anything that's changing per hour or per minute or per second. Okay, it just means that it has some rate of change, and that's its derivative. But anyway, they're saying, what is the rate of change of total delivery calls? Well, remember, F is the total number of calls, right? So the rate of change of total delivery calls is just F prime, but it's with respect to time. So a lot of students would just derive this the way it is and derive X to get a 1, and that's not how this is going to go. You have to derive X and get dx dt because we're deriving with respect to time. So we're actually finding df dt, which you can write that as F prime, but it's kind of misleading because F prime of X looks like you're driving with respect to X. Okay. But all we're going to do is the quotient rule here. Everybody sees that, I hope, which is low d high, right? So we're going to write the denominator, derive the numerator. That's going to be 2x dx dt minus high d low. So that's going to be x squared minus the derivative of the denominator, which is not -2, it's -2 dx dt. And that's all over the denominator squared, which is 200 minus 2x squared. Okay, and all they want us to do is plug in all this junk. They want to know what's the total rate of change of this. So x is 60. So when you plug a 60 into here, you're going to get a 120, right? So 200 minus 120 is an 80. 2x is 120. dx dt is -7/4 minus x squared is 3600 times -2 times -7/24. Okay, over 200 minus 2x again, that's one, it's 80, so over 80 squared. And you can simplify that down with a calculator if you want. We can simplify this down a little, it's gonna bother me. Like this 4, this is 7/4 here, right? So the 4 and the 120 make a 30, so it's really 80 times 30 times -7, minus, again, you can drop this to a calculator. We don't really need to do all this work. This 2 is going to first off make these both positive, right? It's going to make this a 12, but then there's also a 3600 over there. So the 12 and the 3600 are going to cancel out to a 300. So that's just 300 times 7, and that's all over 6400. Okay, that's not really super crazy important, but that's going to be, our units on that are going to be hundreds of beats per hour, right? Oh, no, delivery calls. Hundreds of delivery calls per hour, yeah. Okay. Hoi.
Mrs. Smith.
Yeah.
Spencer noticed that you forgot 24.
Where?
And 80 times 120 is negative 7 over 4 instead of 24.
I don't make mistakes, man. I don't think so. Where? No,
Whatever.
I still don't see it. Where? Hold on. We have this right here. This is okay.
The first dx dt.
Yeah. I made it a 4 instead of a 24?
Yeah.
Oh, man. Okay, let's just leave it like that. Gosh darn it. Okay, get out of here. That's embarrassing. Thank you. All right. Man, so my other video I made too, I made a small mistake in one of the questions as well. Like, everything's correct, just one tiny computation I messed up. And if I just left it the way that it should have been and not simplified it, I would have been fine. But either way, if there's a 24 there, you're right. And what are the units on this? How are we feeling? Do you guys know what the units on this are? Okay. Cool. So this is just hundreds of calls per hour, okay? They tell us in the question. I don't know if you guys don't want to answer me. I thought maybe someone would speak to me, but that's going to be hundreds calls per hour. Okay. All right. So that's that one. I hope that one wasn't too bad. This one, the first one of these was a mess. Well, I'm going to go over that again. But we got a little bit of time, so I'm just going to grab the next question. Get that out of here, which is question 1 right here. I'm not gonna have time to go through question 1. I don't think. I'll do that with 6th period tomorrow, okay? And I'll post a video for that. But right now, let me stop this video.